Now, regarding the red soils, how these red soils behave, how these soils are formed. Very first, we can see soil formation. The name red soils, because mostly red means is nothing but these are developed from the sesquio oxides. Sesquio oxides means nothing but iron and magnesium oxides that have developed an archaeogen. That's mostly we can see that granite and acidic type of parent material will prevail here. And followed by general red soils are formed on where we can see this type of soils, we can see in a well drained and stable higher landforms. In higher topographic conditions, we can see this type of soils. Despite in black soils, we can see mostly lower type of topography we can see, but in red soils, we can see in a higher type of topography, we can see this type of soils. Followed by, and where we can see this type of soils, we can see in hot and semi-arid to humid and subtropical climate is well suited for these soils. And the weathering is moderate, intense, and leads to the enhancement of decalcification. So all these property, all these climatic conditions and weathering conditions, we can see there is a enhancement of decalcification, and due to the higher topographic conditions, there will be a completely decalcification we can observe in the red soils. And of course, SQ oxides is another reason for the decalcification. And some weathering products are leached out, leaving behind the less mobile elements like silica, iron, aluminium will be left out here. That and mostly iron and aluminium are under oxidized condition from the SQ oxides and impart the red color. The red color of these soils, the color is came because of the oxidized condition of iron and aluminium. And during when weathering was happens, what will happen? We can see the all the materials will be leached off or washed off, except these elements like silicon, iron, and aluminum will be left off. And what are the other names? What are other popular names of these soils? We can say red loams, they call as red loams, red earths we can call, and red and yellow soils. These are the popular names, other different names of these red soils. And brown soils are called parva, while red soils are called rakhar soils. These are the other local Indian names. And what are the silent features? What are the silent features of these soils? We can see red to yellow, mostly hydration coating because due to this color is imparted, as I told, because of iron aluminum oxides of most 30 to 40 percentage iron and aluminum oxides we can see. Followed by, we can see the texture called loam sand we can see, and a clear type of texture we can see, and shallow to deep soils we can observe is another silent features. And followed by low to high clay and kalanitic and elytic type of clay we can see, low water holding capacity and nutrient holding capacity we can observe in these soils. And well to excessively drainage as evident of the of their color due to the good drainage condition and good other has all the bases will be leached off, and this iron, aluminum, and silica will be left out because of this excessive well drainage. And the color, as we already discussed, of the red color. And a CN ratio will be around 10 is to 1, and a pH will be 6 to 7.5. And CEC, cation exchange capacity, is very low, 25 to 40 centimole kg of clay. And BS means is nothing but your base saturation is low to medium. And silica to sesquio oxides, silica to other sesquio oxide ratios 2.5 to 3 ratio will be there. And a low nutrient status, mostly we can see very low in organic carbon, nitrogen, phosphorus, and potassium, and lime will be very low in this type of soils. And out of constraints, what are the constraints? So out of the silent features, what are the constraints? What are the problems with these soils? We can say shallow depth is from elevation type of this shallow depth. Why? Because the soils be located in a higher topography. So we can see there is a it is a shallow depth we can see, and the soil erosion is a big problem in this type of soils. And the subsurface hardening is very popular in this type of red soils. And the surface crusting, if the soils were exposed to the naked to the nature, what will happen? We can see there is a good surface crusting will be there, and a rapid drying will be there because of poor water holding capacity, and excessive drainage or sometimes runoff will be there, and high surface soil temperature in dry areas, and deficient in organic matter, nitrogen, phosphorus, and calcium, and high in iron oxides and aluminum oxides, kyanite and allophines. And due to the presence of allophines, we can see there is a phosphorus fixation will be there. And even though despite K is sufficient, faster depletion due to the continuous cropping will be there. Even though potassium is rich in these soils, due to the intensive cultivation, we can observe the potassium deficiency in this type of soils. So crusting and hardening. So as we already discussed, why this crusting and hardening was happening in this type of soils? Reasons because Proper proportion of clay to sand plus silt ratio is 3 is to 7. So due to this imbalance in the clay to sand and silt ratio, we can see this hardening and crusting, and the presence of free iron oxides, which irreversible bonds with the clay fractions will be there. Due to the free availability of free iron oxides, we can see irreversible bonds will be formed with the clay fraction. And sealing the pores by raindrops, yes, this is a very popular in the crusting. Due to the sealing, what will happen? The dispersion of the soil particles will be taking place due to the sealing of pores by the raindrops. We can see there is a dispersion of clay particles. And how to manage? So management is nothing but tillage with a spike roller or a pull a thorny bush to break the crust. So whenever we feel any this type of crusting for a crust are present in the red soils, we have to pull to a thorny brush or break the crust. We can, or with the help of spike roller, we have to use it. And mulching is very popular to despite to avoid the crusting or other erosional issues in this type of soils. We have to go for mulching, and the seed line sowing and sledges are very important. And incorporation of slowly decomposed organic residues we have to use, so that will enhance the organic matter content. Mostly, what are those organic residues? Mostly paddy husk we can use, and a groundnut pot shells and coir pith, very popular. And it can also sometimes give a physical or moisture holding capacity also can be improved with the help of the coir pith type of mulch. Potential. So, in spite of all the silent futures and potential, what are the potentials we can see? We can say under good management practice, these are good for agriculture, horticulture, and plantation crops. Management. How to go for management? So these are the application of organic matter and proper fertilization is required. Thank you.